All right, today on the bench, we're gonna take a break from the HP 5245 sitting over there. Still haven't decided what I'm gonna do with that yet. While I'm thinking about it, what I'm gonna do with it rather, decided to take a look at this. Take a little break from that frequency counter. This is an HP 8620C. That's a sweep oscillator mainframe, and it's got a plug-in module, which is a 2 to 18.6 gigahertz. It's a 86290B plug-in module, and I think the mainframe, as far as I can tell, works. But there's a problem with the plug-in, and the problem with the plug-in is the RF output is low. It's very low. So what I'm going to do is I'm going to go ahead and hook it up. I'm going to hook up some test equipment, and we'll show you what it's doing right now with the output power, and we'll go from there. All right, so we've got the unit set up now, and just real quick with the setup, what I've got here is just a resistive power splitter, and we're going to look at the RF power out, looking at the power meter there, and we're also going to look at the on the other channel, we're going to look at the frequency into the frequency. So we're looking at the output frequency here and the output power here on the power meter. So what we'll do is we'll turn the RF power on. All right, and we're set for, we'll put this in CW, and we're set on band, I think it's band 1, it's the 2 to 6.2 gigahertz band, and we're sitting at right at 2 gigahertz. So looking at the frequency counter, you can see we're sitting here at 2 gigahertz, and our output power is minus 19 and a half dB. Now, I know there's a 7 dB loss in power across this power pad. So whatever's coming in from the RF output to the power sensor, there's going to be a 7 dB loss. So if we're looking at 19 and a half dB going into this power sensor, we're looking at roughly 13 and a half, minus 13 and a half dB coming out of the RF output. And so we could also, so we're set to internal on the ALC loop, and we can go ahead and raise the power level out all the way up, and I'm going to adjust it off camera, but I'm adjusting it full range, and there's not really any noticeable change. So what we'll do is we'll go ahead and run it through. I'm going to run it through the band here, and we'll just run through the first band up to 6.2 gigahertz. I'll let my frequency counter catch up. It's kind of slow. All right, so right now we're right at 4 gigahertz, and we're still showing 4 gigahertz on the frequency counter. We're showing a negative 21 and a half dB. So I'm going to go ahead and raise it all the way up to 6.2 gigahertz. So now we're at 6.2 gigahertz, and 6.2 gigahertz still showing low in power. All right, and one more quick look. We'll go ahead and switch the band. All right, so now we're at we're on the full band. This is the 2 to 18.6 gigahertz, and I've got the CW all the way up to 18 to the top of the range, 18.6 gigahertz, and it should be indicating light here, but these bulbs are burned out, so we'll look at that. But as you can see now, all right, so we're still showing a low power, minus 24.3 dB, but now it looks like the frequency counter has power is too low to actually make it count. So there's an additional loss. This isn't I don't think this cable is rated for that full, I don't think it's rated that high of frequency. So we're getting enough loss in the cable where we've lost our, between the loss in the cable and the loss on the pad, on the power splitter, we've lost enough to drive that frequency counter. So that's the issue that we're dealing with, and it's low on all the bands. This is that's the 12 to 18.6 gigahertz. We'll just put that back somewhere in the middle here, and still showing low. And this is the 6 to 12 gigahertz, and back to the all right. So we're back to the low band. We're back at 4 gigahertz, and so now we've picked up enough. Now the frequency counter's reading the amplitude again, or the reading the signal again, counting the frequency. So that's where we are with this this module. This power output is low. So the next thing we'll do is I'm gonna get the service manual out. I'll get the service manual, and I'm gonna disconnect all this, and we'll take a look at see if we can figure out what might be causing the problem. All right, look at this is an overall block diagram of this this plug-in module. So here's our RF output that we were looking at taking the readings from, and you can see from the signal diagram here, it starts with a Yigtune oscillator down here where the signal's generated. It goes through a coupler modulator, power amplifier. So all this A9, A10, and A11 are all part of this main this RF assembly right here. So and there's an aux out on the back, and that you can read the signal. And I did check the aux out, and it's reading 2.0 to 6.2. It reads that output goes out, but that's good, because that at least tells me that there's something coming out of, there's a signal coming out of the Yigtune oscillator. But after that, it goes through a power amplifier, and then it goes through a 3 dB attenuator, and then it goes through a Yigtune multiplier. So that multiplier takes the 2.0 to 6.2 gigahertz signal and multiplies it to get the full range of 2 to 18.6 gigahertz. Then it goes through a directional coupler into the RF output. Now the directional coupler feeds a detector diode, and then it goes to the A1, which is the ALC amplifier. And the ALC, this is the automatic level control amplifier, is what is used to feed back to drive the Yigtune multiplier, and it drives the coupler modulator to control the level of the RF output. So if the ALC is not working correctly, that could be one of the reasons why our output is low. So I'm going to start with the ALC amplifier, which makes the most sense. And we'll start with that, and we'll look and see what we can figure out. These you got to really appreciate this HP equipment. This is the bottom of the module, and they've included the extender board so that we can take all of these boards. I'll flip this back over. All of these boards right here. That extender board fits these boards, so we can stand them out and take readings. And this one right here, this with the brown tabs, is the A1. This is the ALC board. So what we're going to do is I'm going to reinstall this module. We'll put it back in the mainframe there, and we'll put the A1 board up on the extender so that we can take some measurements. And I think the first thing we'll do, we'll start with the voltage, the power supply voltages, make sure they're all there. All right, so here we are. The unit set back up here. It's powered on, and we've got the A1 ALC board up on the extender. And this is the coax, the coaxial cable that actually feeds the signal. You can't see it, but inside this unit is the RF, the detector diode, the CR1 that we looked at, and this coax feeds that DC signal into the ALC board so that it can sample the output power from the RF output. And so I got that connected, and I read in the manual that we need to make sure this is connected because this completes the ground circuit or the return path for this board. So with this being connected, so we got that connected, and so now we're going to look at the schematic here. So I've got the schematic, and it's rather large. This is the A1 assembly. So the first thing we'll look at is find our power supply. So here's the detector diode CR1 and the coax that we've got connected there. Let's see, power supply. All right, so here's our power supply. We've got a plus 20 volts and a minus 10 volts going into the board. And so this is our YTO driver. That's not a power supply. These are all front panel controls, and these are the drive signals from the 8620C mainframe, the sweep and the markers and whatnot driving the module. So we're looking at a plus 20 and a minus 10 volts. So I've already got the voltmeter hooked up. We're looking at DC volts, and I've got the common lead just attached to the chassis for a ground. And so the first one we'll look at is the plus 20 volts. It is on pin 2. So looking at so there's pin 1 right there, and we will look at pin 2, which is right there. And so we got a good, that's 20 volts. All right, the next one we're going to look for is the minus 10 volts. That's at pin 3 and 22. So again, all right, so now we're looking at pin 3, which is here. And looking at minus 9.8 volts, which is pretty close to minus 10 volts. And on the back, pin 22 is this one right here. It's just the reverse. Let's see, that's 19, 20, 21, 22 right here. And we're reading the same, minus 9.8 volts. So we got our power supply. We know our power supply is good. All right, the next thing we'll do, so here's our supply filtering circuit. You see plus 20 volts, minus 10 volts. And once we go in here, we'll check. So let's look at this R9. There's a Zener diode here that develops a plus 5 volts. I'm not sure what the plus 5 volts goes to. I'm going to look at the schematic. All right, so I've looked at the schematic for this A1 board, and it looks like the only place I can find the plus 5 volts is right here. And this is interesting because if you look, this is the detector compensation circuit, and there's a plus 5 volts here and a plus 5 volts here that go into this circuit, and that comes off of the YTO driver, and that signal from that detector compensation goes into feed the reference and symmetry, and then it goes on from there to feed the power level control, and then on out to it looks like that's the upper and lower level clamps. But anyway, the fact that circuit looks like it feeds the front panel power level control, that looks something interesting. So we'll take a look at that next, and we should be getting. So I'm trying to figure out. I think the best way to look at it, because it's not going to be on the connector plane. So we'll need to find where R9 and VR1 are, and then we'll have to take a reading on the board. So looking at the board for the A1 board, R9 is right here. So here's R9, and VR1 is, let's see, I'm not seeing it on here, but I'm thinking this might be, it's not labeled, but that's being at its close proximity, that's probably VR1 right there. So we'll take a reading on R9, and we'll see, and we'll take a reading here on this diode here, which I presume is VR1, and we'll see if we got a 5 volts there. So here's where VR1 is, and then this would be R9 here. So if we look at the cathode of VR1, which is down here, we should see a 5 volt signal. So we're looking at the cathode, and our multimeter is showing minus 0.2 volts, minus 2 millivolts, 200 millivolts. Okay, so that was the cathode of VR1, and also the junction of R9. So that should have been plus 5 volts. So I'm pretty sure that anode's going to be at ground potential. We can check that. Again, looking at the ground potential here of VR1, and it's at ground. So if this is R9, see if we can take a reading here on R9, and R9, that lead there off R9 shows plus 20 volts. So that is what it should show, 20 volts. And we're getting minus 200 millivolts on the cathode of VR1. So I think what the first thing we'll do is I'm going to go ahead and power the unit off. We'll take that board out, and we'll take some readings, we'll take maybe resistance readings, and we'll take that diode out of circuit and check the diode and see if that VR is working. We've got our diode out now, and let's test it and see what we get. Alright, so that's showing a good diode junction. Now, the other thing we can check is that resistor right there. So now that it's... Alright, so here's our pad down here for the cathode of that zener. And so it should be isolated. We'll take a resistance reading, and we'll see what it shows. Alright, so we're clipped on there, and to this pad, it's showing 3 kilo ohms. So the schematic says 825 ohms. I don't know if that's parallel resistance, but we'll pull it off the board and take a reading out of circuit and see what it's reading. Alright, I've taken the resistor R9 off the board now, and I've got it hooked up to the multimeter with the mini grabber clips, and the resistance is showing 6.3 mega ohms. And if you remember from the schematic, it should be 825 ohms. So that's definitely questionable. What I'll do is we'll take a look and see in the manual here what it should be, and we'll put a replacement part in there. So this is the A1 board, R9, A1 R9, says it's a 825 ohm, 1%, looks like 1/8 watt resistor. I know I've got some of those resistors. We'll get get a new resistor, and I guess I'll go ahead and replace that Zener diode since I pulled it out too, and we'll see what happens then. Alright, and back with our repairs. So I went ahead and put a new 5.1 volt Zener diode in there, which I didn't have the exact HP part number, but it's a 5.1 volt Zener nonetheless. And I put in a new, it's an 820 ohm 1% metal film resistor, and that one's a 1/4 watt. So that should be, it should do well enough for that Zener. I'll plug it in and see what happens. The units, we were sitting back here again. We got the A1 board back in the mainframe on the extender board. And one thing I noticed that now the unlevel light's lit. And, turn that on. So the RF is on, so the unlevel light just went off. So that's a good sign. That's definitely something different that wasn't happening before. Alright, let's see. Let's take a reading on the cathode of our Zener diode down here. Should be reading right there 5 volts, which was not reading that before, so that's good. Alright, so we got 5 volts where we should have 5 volts. I'm going to go ahead and hook up the power meter again and see what our output's looking like. Alright, so moment of truth. Now I've just got the power sensor hooked directly to the RF output, and right now we're not showing any power, so we're going to turn it on and we'll look at the power meter. Actually, what we'll do is I'm going to go ahead and turn this all the way down so I don't, in case that comes on too high. And now we'll turn the RF on. Okay, that's a good sign. So we've got the power level all the way down to the minimum, and I'm reading about minus 4 dB. So let's take this up to mid-range. And we're reading, it's kind of climbing around there. Oh, you know what? That's because we're in sweep mode. Let's put this on back in CW. The unit always goes into sweep when you turn it on. So now we've got the unit in CW. And now our power level is constant. And I'm going to go ahead and raise it up. Alright, so now we're at the maximum extent of the power range knob, and we're looking at 8.7 dB. And I'm going to take it down to the minimum, and we're at minus 2.7 dB. And now we'll flip it to the full range. So this is 2 to 18.6 gigahertz. And we'll take it to full travel. And what you're seeing there on the power meter, see if it does it again. There's points on the right there where it drops off. There's points on the as you span across the band where the circuit when it changes bands, it does that, and it drops out momentarily, which is why that's doing that. And they're marked here. These markings there at that little square and that little square up there. Those are the points where the bands change, and you get that little spurious drop out there when you hit those marks. So it looks like for mid-range on the power level, we're at 4.3 dB at the top of the band, and about middle of the band we're at 3.4, and at the bottom of the band we're at 1.8. So I don't know. I haven't looked at the manual to see if that is within spec. It seems to be a fairly significant change in level power across the band, but yeah, I know these aren't entirely accurate compared to some of the more modern generators. So that may be within the acceptable level. But anyway, we'll go ahead and see what our do a full sweep of the band, and we'll see what our full power as we go up. There we go. Of course, we gotta keep it there at 18.6. You can it looks like the dial may be slightly out of calibration. So if you roll it too far, it'll drop off there, and that's actually I think higher than it's supposed to go frequency range. So there's the top of our band, and tell you what, let me do something. All right, so what I've done is I've gone ahead and hooked up just like we had before with the power splitter. I've got the frequency counter and the power meter, and so we're looking at the bottom of the band here. We're looking at the full band. This is the 2 to 18.6 gigahertz, and we know that we've got a 7 dB drop in power across the power splitter. So when we look at this power reading, we need to add 7 dB to the reading. So that would actually be 8.5 dB, and we're just right under 2 gigahertz. So I'm going to go ahead and raise this up to let's see. So that's 4 gigahertz, and so we're looking at 4 gigahertz, and looks like we lost about 0.3 of a dB. Take this up to 6 gigahertz. And up to 8 gigahertz. At 10 gigahertz. This is 12 gigahertz. 14 gigahertz, and 16 gigahertz, and 18 gigahertz. So there's our, looks like we've got power at we've got the right frequency, and we've got a decent power level all across the entire band. So that's good. So I'm gonna call this a success for now, and probably see if I can change those indicating lights. But and then maybe take a look at the manual and see what the actual what the spec is, whether it's in spec or not. It probably is. It probably needs to be calibrated, but I think I'll call this a success, and that's all for this video. I've got a couple more pieces of equipment that I'm planning on working on, and still make a decision on that HP 5245. See what I need to do to get that thing working. But anyway, that's all for now. Thanks.